Well, hello, and on behalf of the AWA and the Tasmanian Branch Committee, welcome to our webinar on enhancing time series data to prevent sewer spills. My name is Brad Davey, and I'll be your MC for today. I'd like to start by acknowledging and paying my respect to the Tasmanian Aboriginal community, the Palawa people, as the traditional and original owners and continuing custodians of the land on which our Tasmanian participants are joining from. Personally, I'm joining from Hobart and would therefore also like to specifically acknowledge the Muwinina people and pay my respects to their elders, past, present and emerging. Many of us are joining this webinar from our homes and in these unusual circumstances. And whilst we're working on a tested platform today, please bear with us if we encounter any hiccups or we lose our presenters due to home internet. We have two fantastic presenters lined up for you today in Matt Jordan and Andrew May. Matt is a civil engineer with 15 years professional experience in asset management, design and project management within the water and wastewater sector. He is currently working at TasWater as the manager of network asset performance. Matt has extensive experience in the water industry, having worked in both Australia and the United Kingdom. Andrew has more than 14 years experience in systems engineering, project management, consulting, MES design, control system design and commissioning within the utilities, process, mining, oil and gas, automotive, defence, food and beverage, critical infrastructure and manufacturing sectors. Andrew specialises in business optimisation as part of the Nukon senior leadership team, helping businesses understand and implement their strategic vision using technology and delivering innovative and awesome projects for customers. We'll kick things off shortly with a joint presentation from Matt and Andrew, after which there'll be a Q&A session. If you'd like to ask a question, we kindly ask you to use the Q&A function, which will collate these for facilitation by myself during the Q&A session. This function also allows fellow participants to like a question, which determines the ranking order of questions if we are unable to get through all of them in the time available. Secondly, I'd also encourage you to use the chat function for general comments as a great way to engage with fellow participants. Lastly, please also be aware that as participants, you can choose the webinar appearance by selecting to see the presenter and slides only, or other speakers too, which are gallery and speaker view respectively. Thanks for joining, and I hope you enjoyed today's webinar. And now it's over to Matt and to Andrew.
Thanks, Brad, for the introduction, and thank you, Australian Water Association, for allowing us to present. A quick overview of today's presentation. We will start off with talking about the challenge that we had at a location called Midway Point. We'll also talk about some asset management that we undertake on our sewer network, and then talking about the solution and how we reached out to Nukon and Andrew to help us implement a smart way to monitor our network. And then we'll have a brief discussion about the results and how we're tracking with this solution going forward. Oh, sorry, over to Andrew.
Thanks, Matt. Good to be with you today. Just a little bit about Nukon. So we are part of the SAGE group, which is in all locations around Australia. We have a growing team consisting of analysts, consultants and developers. And we basically have 20 plus full-time roles around Australia, and we cover most industries, but obviously what we're here to talk to you about today is our work in infrastructure and utilities. And this innovative solution, I believe a world first, which we presented some time ago in a different forum, but a world first for the water industry, and certainly a first for Tasmania and for Australia. So thanks, Matt. Great to be here. next slide. Thanks, Nat.
Okay. For those who don't know, TasWater is the Tasmania's primary water and sewage service provider, looking after all water and sewage in the state of Tasmania, including the 2 islands, King and Flinders, in the Furneaux group. We were created by the formation of 3 regional water bodies and a common service provider back in 2013, and before that, the amalgamation of 29 councils and 3 bulk water authorities in 2009. A quick overview of TasWater and our infrastructure. We have nearly 205,000 water customers and 180,000 sewage customers. We look after about 11,000 kilometres of pipe, of which 4,700 is sewer mains, and have approximately 970 pump stations scattered across the state, with about 780 of those being sewage pump stations.
Okay, so this slide is really about digital transformation. So this is something that we've, Nukon and the Sage Group, including our automation team, has been helping TasWater for some time. If we can just click on the animation, please, Matt. Yeah, great, thank you. So pretty much all of the digital transformation projects and utilities typically start out like this, with we move through a number of phases, getting to more capability. The first stage of which is getting things integrated, then making the business situationally aware, moving towards an efficient response, being able to leverage the foundation and the basics that you've implemented in the first phase, and really being able to action that more efficiently. And we're going to be talking a bit more about this today. And then for more advanced customers, then we can move into the upper 2 phases, which is really around predictive control and then optimizing that process end to end. So TasWater have been working with us for some time on this digital transformation journey, for lack of a better word. Matt, if you just click on the next animation, thank you. So there was a number of things that came together to help facilitate moving up this curve. So the first one was really bringing all of the SCADA systems together, which has been, as Matt mentioned, happened post merging of the individual authorities into TasWater's statewide authority, implementing some core infrastructure in the back end, which in this case we're going to be talking about an enterprise historian platform called the PI system. Beyond that, some data modeling in the enterprise historian, and some key aspects around ad hoc analytics, which was really capability introduced specifically for this project around process analytics and the ability to look at the data differently. Moving, from this point onwards, we'll be really talking a bit more for future projects about some new capability in workflow automation, predictive control, and that optimized state. So very few people, I think, get to the very top of this curve. Most people, most of our customers sort of tend to be operating in the efficient response or predictive control mode for more advanced customers. Back to you, Matt. Thanks.
Thanks, Andrew. So to understand the story of this case study, we first need to have a little bit of an understanding of our sewer network, or sewer networks in general, and some asset management that we take on them. Spills, unfortunately, are a reality of managing a large sewage network. We actually have about 2,000 sewer mains breaks and chokes per annum, which equates to about 40 breaks per 100 kilometres of main, and that is a nationally reported number. So we compare ourselves against other similar utilities on this front. Predominantly, these mains are lower critical mains, and they're a run-to-fail asset. We have approximately 110,000 individual assets from manhole to manhole. So that's a lot of mains. I guess for the higher critical mains, we actually have a different maintenance strategy on that, being avoid fail. Essentially, we don't want those mains to fail because their consequence is deemed as unacceptable. So we undertake a program of proactive maintenance practices on those critical mains and reactive maintenance practices on the more run to fail assets. We also have a program of relining and renewal. This is generally done on the poorer structural condition grade mains, less so than, you might have a perfectly structurally sound main, but roots are entering that system. So generally that they go on a proactive maintenance program as opposed to renewal. The anatomy of blockages throughout our network, they're predominantly roots, tree roots getting into our mains. About 70% of those 2,000 blockages annually are tree roots, and then followed by foreign objects. So we have different maintenance strategies based on the likely failure mechanism. That being roots and fats, oils, greases and silt. Water jetting is an effective maintenance, and root cutting is an effective maintenance program. And I guess, for example, for foreign objects, you can do the most diligent root cutting program in the world, but a foreign object, someone flushing something down the toilet that shouldn't be, can spoil any plans of a great maintenance program. And we're always looking at ways to better understand and predict where those blockages will occur, and minimising the risk and consequence. So on to the location in question. So Midway Point is a small little satellite suburb of Hobart, about 5 minutes to the east of the Hobart Airport and 20 minutes from Hobart Central. It has one sewage treatment plant, 9 relatively small sewage pump stations, 27 kilometres of gravity mains, 1,200 customers, predominantly residential. A lot of workers head into Hobart for their work. But this idyllic little spot is surrounded by a sensitive water, as you can see, and that location is called Pittwater. Pittwater actually is the largest oyster lease area in Tasmania, comprising of 14 hectares of intertidal leases managed by a multitude of different businesses and ages of oysters as well. In addition to the large quantity of oysters, it is also an internationally recognised Ramsar wetland with significant endangered bird life and aquatic animals in that area. So when you join a sewage system and oyster leases and protected environment, and knowing that we have spills, and when they do occur, it's never always a good outcome. So we have the occasional spill, and it usually makes the newspaper, both locally and on a national scale. Not only that, is we are actually impacting the environment as well as the oyster growers. They have a 21 mandatory day shutdown, so they cannot sell their product for 21 days. And if it happens at the wrong time, and I guess a great example is the middle one there, it was actually on the 6th, that's out of the newspaper, on the 6th of the 12th. So 21 days, unfortunately, pushed that right up to Christmas's front door. It can have definitely economic impact to those local oyster growers. So how this project evolved, back on the 24th of August in 2017, we had a call up from a local resident at about 10 o'clock at night saying that there was a manhole overflowing. Our crews went out, determined that we were actually having a spill from our our manhole, and that it was actually making its way to the stormwater and into the bay. That, of course, essentially caused an incident, and the Oyster Growers Association and everyone else was notified, and we had a clean up and everything else. As part of the wash up out of this incident, and it had happened, quite a few times in the previous years, we thought there must be a better way to actually detect when we were having a spill, because essentially we actually looked at our SCADA data and went back through time and said, to estimate that 6,000 litres, we actually used, our SCADA data to determine how much we'd spilt. We thought, actually, there must be a better way for us to actually undertake a real-time analytics, as opposed to only looking back in hindsight. So the challenge here was that we actually had very little visibility into the network. We have quite a lot of monitoring on sewage pump stations through our SCADA, but to install instruments and monitoring on every single manhole is currently cost prohibitive. And the notifications we have are really reactive. They come from customers who notice that spills are taking place. So with that understanding that we actually had existing monitoring at our sewage pump stations, we tried to determine whether there was a way to utilise that data to predict or to help us understand when a blockage was forming. So what drove this project, and it actually comes straight down to TasWater's vision, which is to be a trusted and respected provider of essential services that is making a positive difference to Tasmania. So if you think about having a spill into that type of environment, we have community safety, that we're selling, those oysters can be on someone's plate the next day. There's the environmental impact to the Ramsar wetland, internationally recognised. There's impact to the local economy, with the oyster growers having to shut down for 21 days. There's also reputational damage, not only to TasWater, but to Tasmania's clean green image when this makes news across Australia. In addition, there's a lot of internal costs and external costs involved in running an incident of this nature. So once we'd sort of decided that actually there was definitely a project here to investigate, we reached out to Nukon, who'd been helping us implement our OSI soft strategy to help us formulate a response and a trial to see how effective it could be. Over to Andrew.
Thanks, Matt. Yeah, so technically speaking, I'll cover off a lot of the aspects of the solution today, but an important part was really our delivery approach. Being essentially a world first and quite a different approach to this problem, we really took a very collaborative approach with Matt's team, as well as SMEs within my team, to really pull apart what was available from a telemetry perspective and trial a few approaches to solving this problem. I think before the project kicked off, we were very confident that we could tackle this type of problem, not only in a very cost-effective way, but also using not being bound by sort of the traditional approach. We could definitely explore avenues to use real-time analytics on the foundations that we'd already deployed for TasWater over a number of years. So it was really a collaborative and project which was delivered in a number of small iterations to really make sure we got it right and was able to deliver on the outcomes. Let's move forward. Thanks, Matt. Okay, so the real benefits of this type of approach is it's very, very fast to deploy. So in TasWater's case, they've already made the investment in the back-end infrastructure, so we were definitely able to leverage that for the purpose of this project. And that includes the enterprise historian backend, and it was really, there wasn't a lot of gaps for us to fill in terms of having some basic data and a small data model to help with this project. So we're able to, obviously the goals was to try and reduce the number of significant incidents and actually help TasWater in responding to those more quickly. So instead of hearing about them from their customers, we would be able to know about them ahead of time, predict when they may occur on SPS sites, and in fact then deploy a crew after some eyeballing of the current situation. We'll talk about exactly how that happens, but then deploy a crew directly to the site to either prevent the spill from occurring or reduce its impact if it was, something that was developing very quickly. So really what we deployed for this project was some sophisticated analytics tools that could be used for ad hoc, real-time and historical process data analytics. And we didn't require any new equipment to be deployed to the SPS sites. We are only using what was already available from the field telemetry, and we are using some very trivial inputs to actually get some very important insights from the field. So not only does this help us understand what's happening, it also helps us be much more responsive and reduce the risk of these issues occurring in the future. So I'm going to talk about technically how we achieve that. Okay, so this is not going to mean a lot to most people, but I just wanted to show it for just to give you an idea that the enterprise historian layer has a capability in there to do some modeling and analytics. So we utilize that capability to take some very simple inputs from the field and develop some more complicated analyses using those inputs and after cleaning up the data. So next slide, thanks, Matt. Okay, so the bulk of the work is actually done in a tool called Seek. So Seek is a time series process analytics tool. In my view, it's the benchmark in the market at the moment for time series analytics, and we've applied it to this specific problem, but it does suit a variety of time series analytics problems and is particularly tailored for process engineers. So I'm going to cover shortly a few details about what we're actually looking at here, but for the group on the call, it's really a couple of key things to understand what we're looking at on the screen. So the solid blue line is a dynamic upper limit that is essentially a profile of the SPS site pump operating conditions. So what I mean is based on a teaching range, we know exactly what and how this pump is supposed to behave on that pumping station. So using those bounds, which is the time between pump runs, that's the key thing. As I mentioned before, we trialed a number of methods, and I'll expand on that in a moment. But the key thing is, once we understand what normal behavior looks like, and this is equally applicable to any asset with a predictable behavior. Once we know what normal looks like, we can then determine what abnormal looks like, and then what actions can we take when that abnormal condition is reached. Seek also allows us the ability to introduce other factors into our analysis, which may not be directly related to the time series information that we're actually using as the basis for our outcomes. So that might be things that influence the model. For example, rain events. Now, rain has an impact on the sewer network because of water ingress into pump stations. So therefore it can affect how often that pump station actually needs to operate to pump out. There's additional analytics you can do on the impact of that. But essentially we can apply some rules that adjust our model. Other things that may impact us are things like pumps in manual. So when those pumps are running in manual mode, there's someone already deliberately doing something at the site. So maybe we want to ignore those specific situations from our analytics to reduce false positives. There's some other things we can do from a product perspective, but I won't go into that at the moment. The main thing is that we can, once we have these, once we capture these incidents, we can also annotate and record the details of that incident, including what happened in the lead up. We can document it, and then it becomes a tool for not just the real-time analytics and the decision making, but also for incident investigation and analysis. So if you need to report this, through to the EPA or other authorities as well. Next slide, please, Matt. Okay. So the key thing to really look at here is using that the reference incident, which occurred on the 24th of August 2017. We retrospectively applied our model to that incident, because that was really the the driver for the project. So we needed to be able to detect not only that incident, but also new incidents of a similar type, which is a partial blockage, which means that the automation system won't necessarily tell you that there's a problem. It won't alarm. Everything is normal, but meanwhile you're actually spilling upstream from the pump station because maybe there's a blockage that's started to form upstream. So this is it gives you the ability to be able to detect that those anomalies upstream from the pump station. So in here, again, the upper bound represents the time limit between pump runs, which is a dynamic limit. And when we breach that limit, we're able to, using some criteria defined in the analysis, we can then generate a notification. And the red bar at the top there is actually called a capsule. I'll go into a bit more detail in a moment about what capsules are, but we're able to do a number of things when they are generated. For now, you can think of them as like a bookmark, and the bookmark, is a flag to say that it's an out of specification event that's occurred, and that's can be quite a complex criteria for defining that. And once that's occurred, we can, using some of the functions and the native features of the PI system in this case, we can generate a notification out to the operations control center. And using this method, we're able to historically detect this blockage 13 hours ahead of when the customer reported that issue to TasWater, which would have meant at the very least a significant reduction in the impact of that event, if not being able to prevent it entirely. So this approach really holds a lot of potential when it comes to reducing the impact of these events occurring in the network. Next slide, please, Matt. Okay, so what are capsules? I'm just going to have to talk a little bit about time series for a moment to explain what capsules are. So capsules is a term specific to the Seek product, but what it is essentially a contextualization of what's happening within your data set. I mentioned that it's like a bookmark, but contextualization is one of the many problems that needs to be tackled when dealing with time series data. So one of those is obviously trending and anomalies in trending, data cleansing, calculations that may need to be performed to compensate for anomalies in signals. And what that means is that there's often post-processing required before you can throw the result of that data into secondary calculations for you to get some real insight. In short, a lot of, let's call them downstream systems, don't deal very well with issues in the data set. So in this case, I'm going to talk a little bit more about the actual inputs that we required to deliver the solution. But for now, I think it's just important to cover some key challenges with relation to time series. Next slide, please. Thank you. So in this case, we've got, we might have time, temperature signals and asset operation. And what we want to be able to do is combine all of these. Let's go to the next slide. So contextualization conditions, or what we call a capsule, essentially is a criteria that we've defined on the time series. And that can be, we can start joining these together to actually get very specific about the situations that we're interested in. Next slide. So we can define those capsules by thresholds, Boolean logic. We can also even define patterns for those based on a very specific similarity between data sets, and we can teach the application how to recognize those and then generate events for us. Next slide. So just getting back to the key point of covering this, the solution is essentially built up from a number of different criteria. So what's happening? What do we do with the model if it's raining? What do we do if the pumps are in manual? What do we do if we've breached the boundary conditions for normal operation for the site? Well, to build all of that reasoning up at a technical level, we need to be able to join all of these conditions, stacking them on top of one another like a deck of cards. And then what we end up with is a very, very specific time set and a very specific set of conditions that we're interested in. Next slide, thanks, Matt. Okay, so fundamentally there's Seek, which we're using the main calculation engine, visual analytics, and the user analytics capability in Seek, and that's connected to a little utility that then writes back into the enterprise historian and utilizes what's called an event frame and notifications. For the participants on the call, that is really just a way of sending out an alert. And if you didn't have a PI system, this is still achievable just with a different solution, a different technical solution to work around this problem. So if you are looking to achieve this kind of alerting or process automation, that is possible with other tools as well, not just the PI system, which is supporting this particular use case. Next slide. Okay, so the main outcomes that we achieved in this pilot was really that we're able to detect multiple partial blockages and other abnormal behavior in the network. So we've been able to reduce the impact of a spill through early warning, and I think it's been successfully adopted really as a production toolkit, as one of the tools in in Matt's arsenal to help combat this type of problem. Obviously, it has to work in conjunction with maintenance regimes and some very targeted preventative maintenance. But at the same time, we can use this approach to really detect anomalies, to take action when those anomalies occur. And we can, so far in its operation, which is coming up to probably 3 years later this year, it's really since been expanded to a number of other high-risk pump stations for monitoring. And Matt's been able to take ownership of the model within his team to tune that very specifically to the behaviour of those pump stations. First of all, with a view to reducing and minimising false positives. There's always a balance between being too conservative and missing out on those early warnings, or being overly aggressive and then generating too many false positives. So collectively, when looking at this problem, the project team felt that it was important to take a more conservative approach, a risk-oriented approach, and you know, alert more conservatively to take action and eyeball those sites instead of you know, taking a more aggressive approach and allowing some of those actual blockages to materialize into spills. So in short, we'll continue to work with TasWater on expanding the solution if needed to other high-risk sites. And I'm not sure how many we've got on the solution at the moment, Matt. I think at last count it was around 14, but you know, give or take. And you know, so we're actually monitoring pump stations outside of the midway point area as well at the moment. So next slide. Okay, so I've got a little video here. So hopefully this will play okay. There's there's no sound, so you know, just me talking over it. So if hopefully this will show up. Seems to be coming through okay, although it's a little bit slow for me. So this is a little bit about a seek. It only runs for a couple of minutes. So essentially we have one dashboard per pump station. And one of the great things about Seek working in conjunction with the PI system is that all of these analytics that we can generate for one pump station, because of TasWater's approach to telemetry and templates and good conformity between the sites, what we develop for one pump station, we can apply equally to any other pump station. There's a few tuning parameters that need to be set for the specific operation of the pump stations, but what that really means is that we're able to scale and expand the solution to other like assets very easily, and with some tuning, it allows us to set the parameters for the model very easily. This is where we rely a bit more on the SMEs, and working in that collaborative approach with the customer, because as a consultant coming in, it's very difficult for me and my team to understand exactly which period we can trust it's been a good operating set of conditions for that asset, and this is where we need to really work together on coming up with that criteria, because that is really key to determining what is good normal operating behavior for the asset. If you model the behavior on you know, bad operating conditions, you may be able to take the reverse approach. You could teach it what bad behavior looks like, but you know, I think the correct approach is to understand what does your good normal operating profile look like for the asset, and then work from deviations from normal, because that will monitor by exception essentially. So what we're showing here is being able to swap the asset out for a number of different assets, and we can choose how we actually do that. And Seek will consume the data model from the enterprise historian. So as new pump stations come online in the SCADA system, as they're added to the enterprise historian, there's no additional work to do to actually consume the model into Seek, and as soon as it's available there, we can add it to the data model, tune its parameters, and away we go. So it becomes a very small amount of effort to be able to roll that out to additional sites. So what we're showing in the video here is integration with the event frames. And the event frames is something that's unique to the PI system, but essentially what that is a bookmark with a start and an end time, and a number of parameters that are collected during that event. And once you've collected those, you can come back to them. You can annotate them. You can use them for future reference with respect to reporting, and really gives you the ability to catalog that in a good way for incident management or incident reporting. So I think we can move on past the video now. Thanks, Matt. Okay, next one. I think this is a point I think where we're open to questions. I think we've got quite a few. So Brad, perhaps I'll hand back to you just whilst we sort out the questions, and I'll have a quick look at what's being asked.
Great, thank you, Andrew, and thanks also, Matt, for a very interesting presentation. So I will run through some questions now, and thanks to those that have posted questions in the Q&A. We'll endeavour to get to as many as we can. But starting at the top, we have a question from Duncan. So I'll pose this to both you, Matt and Andrew. How far upstream was the blockage in the example that you showed us, Andrew, in the data you presented? And could operations have easily found the issue before the customer notified them?
Yeah, so this one was relatively close upstream to the pump station. And I guess that's the one of the limitations of the tool, is that if you go right to the very end of the line and there's only 1 or 2 houses, you know, that additional change in operations at the pump station won't be felt. So this was, but equally though, if you're upstream and you're only linked to 1 or 2 houses, then the consequence of the spill may be lessened because the volume's not there. So this was relatively close. I can't remember. It might have been a couple of 100 metres from the pump station, close enough to, and there was enough volume to make it into the stormwater network that then also made it all the way down to the waterfront. So absolutely, our operations could have found that. I guess we don't have people walking the streets continuously looking for the blockages, and predominantly most of our pump blockages are reported by the public, just because, you know, there's public everywhere, and yeah, so occasionally our operators would find it, but predominantly it is the public calling it in.
Right, thanks, Matt. Did you have anything to add to that, Andrew?
Not on that specific question, but I can see there's some other questions there with respect to very small scale solutions. So a couple of questions related to just the size of the solution. Is it feasible to scale down? The answer to that is yes. As a solution for analytics, Seek is very good value for money. So you know, if you've got a very small system with a small number of users, it is a good solution that will scale down to small systems. You may have to select or go to a slightly different back-end solution for storage of the data, or perhaps you already have one, which might be a very small scale historian type solution just to collect the data from the field. I mentioned earlier that we're not collecting a lot of data from the field. We actually only collect the run signal for each pump to generate this analytics. So it's really just one bit per pump from the field, and that's fairly typical telemetry that would be coming in from those systems already. So in that sense, the cost of implementing a solution, obviously it gets to a floor at some point, but it does scale down equally as well as scaling up to larger systems.
Great, thanks, Andrew. We've got a question here also from Chris, who says the envelope looks quite dynamic and changeable. And could you speak to that?
Absolutely. This is one of the key features that is actually sets it apart from traditional automation approaches. So the operating conditions, in this case, we're looking at a dynamic bound. We only care about the upper bound in this case. So if the time between pump runs goes too long than we expect, but the software is capable of having an upper and lower bound. So if you have a process that needs to be within very tight tolerances all the time, we can create what's called a reference profile for that. So that creates an operating envelope with an upper and a lower bound that can be dynamic as well. So at this point, we're getting quite technical in terms of how it works, but I'll just leave it at this to say that it's possible to create a quite a complex operating profile, with the caveat that it has to follow that operation profile normally in order for it to be able to predict or tell you when it's not normal. So provided the operation of the asset has a predictable behavior or an established operating pattern, which a lot of control system assets do. So then we can apply this same process and the same logic to maybe a slightly different problem or a different usage domain, but it's the dynamic nature of the operating bounds is key to this solution.
And continuing from that, one of the benefits here is once it's set up, and a lot of that initial work that was done by Nukon, like there's just the operators in TasWater and even myself, would just believe it, can jump in there and actually review and back test different. Okay, it's now look like it's staying to things have changed. Growth has happened in the catchment. How do I account for that? It is actually quite user friendly in being able to tweak that operating range relatively easily without having to know a whole bunch of coding. So that's a really positive outcome.
Yeah, and also there's a few other questions I think that really expand on that. So how do we determine the difference between normal and abnormal? Well, that really comes from the data set. So the more training that we expose the software to, the more it's going to learn more accurately what is normal. So I think the data set that we had when we initially trained the model, Matt, was about 1 month of good operating conditions for the asset. So that's quite a lot of time series data, but if you've got a complex process and maybe you need to give it a larger training window to start with, and likewise, if you don't have any data, you might need to collect some data first in order for you to be able to train the model. It's very important when you train the model that it is on good, the best possible good operating conditions that you have, because that's going to give you your optimum, your target that you're aiming for all the time. And the tighter you can get on that, the easier it is to determine what is abnormal versus normal. So, and then what we do when we reach an abnormal scenario really depends on the use case. And there's some more technology available to us today that was, that we didn't deploy for Matt's solution back in 2017, but there is the ability to automate a business process directly off that response now. So we can use the user-defined event generation in Seek and hook that up to a business process automation solution that then says, well, every time I get this situation in analytics, I can then automate my response. And that response can be a fairly complex business process as well. So I think there's a couple of other questions on this similar vein. I think we've answered a bit about training data sets. And there's a question regarding level sensors. So this is an interesting one. It might seem simplistic to go, oh, well, why don't you just monitor the level sensor? I can tell you that that's inaccurate. There's actually quite a lot of fluctuation in the level sensor in a normal pump station filling scenario, and the level sensor you could monitor it for its rate of change, but it's too slow. There's a few reasons. This was one of the explored models using like a derivative of the change in level, but it's not as reliable as using this method of detection.
Yeah, absolutely. And I think that was when we went into that, I thought exactly that would probably be the more reliable, but actually going through this process actually sort of teased out that the more robust solution was time between pumps. So that was a very similar thought to what we went through our heads as well.
So I think there's a question here really for you, Matt, as well. When an email is generated from the solution, what's your decision-making process? when making the call whether or not to send out the crew?
So we've nearly got it into an automated process that actually goes to our operations control center. So we've done enough back testing to be confident that we do want to go and investigate these. I've had quite a few discussions with our service delivery managers who are more than happy to send out crews based on a good decision. Even if that is a false positive, it's better to be slightly too cautious. So actually, it's actually a fairly simple process at this point in time. The notification goes to our operations control center, who then call out an operator to go and investigate upstream of that pump station in question. So again, there's one area where our operations control center is heading is into having more robust analytics built into the control center. And in the not too distant future, we may be, there may be some decision about the situation there and then. And I guess a great example of that is public holidays or Christmas time, which are really hard to, which does change what normal looks like, but it is literally one day a year. And so having that local knowledge linked to, about certain circumstances would be a benefit, and that is something that we will explore going forward.
And it certainly is possible to integrate changes around the asset as well. So for example, you may have a secondary model that you need to substitute when specific sets of operating parameters are met. And that could be a time-based substitution as well as a sort of an event-based substitution. And what I mean there is, to Matt's point, if you have a very big change in the operating conditions of the asset, which means that you're kind of switching from one operating profile to another, the software would allow you to do that as well. And I guess one of the key points is, once we've developed this initial pilot for TasWater, the maintenance of the analytics, the bounds and the tuning of the asset behavior is really down to Matt's team. So his team is empowered to go through in consultation with his SMEs and business stakeholders, go through the internal change management process, make the change directly in the software to tune how the system responds. So in that sense, you don't need to pay to fly out a guy from who knows where internationally to come and make a few changes on the system. Matt's process engineers are fully empowered to over the outcomes in the model. So I think this is quite different from some other approaches to this problem.
Okay, I think we've got time maybe for one more question, and then we've got some wrap up to do. So if there's anybody who doesn't get the opportunity to have their question posed to our presenters, I'd just encourage you to follow up. I'm sure either Matt or Andrew would be more than happy to receive an inquiry offline. But finally, I've got one here from Philip regarding the change management process for implementation of this equipment. Maybe one more for you, Matt. But yeah, Philip's I guess mentioned the difficulties that can arise when deploying advanced analytics tools. So I was just wondering if you could speak to how that was managed at TasWater.
Yes, so one of the positives about the Seek tool, it has a great record management of what you change within the software. So you can actually, as long as it's filled out, annotate individual changes to those parameters. For example, you change the training window, you can just annotate that, and it is linked to you in timestamp. So there's great visibility on that front. In terms of change management for, I guess, across the business, there needs to be a responsible officer, and it falls to our team to take ownership of that. And I guess one of the activities we do is often take a copy of the dashboard, and if we want to essentially trial different scenarios, such as a new learning window, we'll actually create a duplicate version with a test environment and allow us to then tweak and try to fine-tune that before deploying that back into the production database. So again, that is managed through our team with a consultation with service delivery, and so yeah, that's how we've managed it to date. Yeah, hopefully that's answered that question reasonably.
I think there's a couple of other things that I think can help answer that question as well, is that TasWater have also made the investment in some synchronization tools as well. And the tools are really between the SCADA system and their enterprise historian. So for example, a change gets made, or a new site is commissioned in the field that has automation equipment that gets deployed to the site. There's telemetry associated with that equipment. There's a good level of templating that's applied right through. So from the SCADA system, then that is cascaded through a change management synchronization tool into the enterprise historian. All of those points go on to telemetry collection. Then, because you've got a high degree of standardization, if Matt wants to generate a new SPS blockage detection profile for a new site, he just switches the context of, duplicates the dashboard, switches the context of the asset, specifies a new training window. So the process of commissioning that is quite quick, and it really leverages the capability of, in this case, the enterprise historian, which is the PI system, and the asset sort of context swapping ability of Seek to be able to do that.
Right. Well, I'd really like to thank Matt and Andrew for presenting to us today. I'd also like to thank our state manager, Natasha, for helping to organise. And lastly, to you all for coming along and for your continued support of the AWA. And we trust you all enjoyed today's webinar. Natasha will email you a link of the recording of today's webinar shortly after we finish. And this will be available for you all to view for 2 weeks. You'll also receive an event survey, and it'd be fantastic if you could complete and return that for us so we can learn about how to make these events even better going forward. And lastly, we'd really like to see you at another one of our upcoming webinars. So to view that program, you can either refer to your AWA member communications, or you can visit our website at awa.asn.au and browse to events and then webinars. Thanks again, and I hope you all have a lovely day.